Hello, welcome to my bench. Today we have something a little more interesting than a clock. This is the IPA module out of a Harris transmitter, and it decided, of course, on Saturday to quit doing its thing. It's out of a Harris FM25K FM transmitter. The job of this thing is to take a small signal in and give me a big signal out. And it died. And of course, it always, as always, it died on a Saturday. Should be used to that by now, you would think. But we're going to see what's wrong with it. I think I know. These are pretty rugged little things. This particular one has been in service and working since 1988. So one of the things we are going to definitely do for sure is replace the capacitors. Fortunately for us, or for the radio station, we have an external amplifier that feeds this, and it produces enough power to be able to bypass this. So that's a good thing. Alright, here we go in here. Oh, yeah, well, right away we got a problem. Take a look. Not a healthy looking resistor at all. We'll follow that through and see what's wrong there. What else is in here? Well, there's a big old 100 microfarad and 100 volt cap. It doesn't look bad, but you know, this thing is driven. The output. This is the power supply board over here, and this thing is driven by a couple of transistors. I don't know what they are. I haven't looked them up yet. This is the way this stuff is built these days. I mean, in the old days, preamp regulator boards just built like a brick dunny. I'm sure that the fuse is still good. We'll check that. You know, you got all these fuses in here. You got all these transistors and diodes to protect these valuable fuses. Yep, fuse is good. Of course it is. Let's see, what else can we get right away? Well, we got some tantalum caps, big ones. What's this one? 47 at 35. 6.8 at 50. Probably the same thing over here. Yeah, 6.8 at 50. And a fried resistor. So we're going to go through and check the diodes and the resistors and see what we got. Alright, so resistor wise, put it on low power. That resistor should be, can't read it, but let's see what it says it is. Fortunately, I got this low power meter. The neat part about having low ohms is it doesn't put out enough voltage to turn things on, so you can actually test, like diodes, it won't turn on a diode, so you can actually test things in circuit and see what they are. Wow, okay. It says it's about 16 ohms. That can't be right. Where is it? It is R2. R2. I think. Ah, CR2, R2. Ooh, R2 is supposed to be 510 ohm, 2 watt resistor, and CR2 is a 1N4742 Zener. So let's check the Zener here and see if it's got anything. We'll try it in circuit first, see if that works. Well, it works as a short, both directions. So that's a piece of wire. We're going to have to test our little transistors here too, see if they're any good. And I got an LM353 and an LM723, and that's about it. No, that's quarter inch. Okay. Huh, where'd that one come from? I don't remember that one. So I have a feeling what we've got here is this resistor changed value enough that this poor Zener couldn't handle it anymore. It kind of went kerpoof. But we won't really know until we get them out of circuit. I mean, it's nice to test stuff in circuit, but you got a 50-50 chance that it's right. And of course we're going to test this big old capacitor back here too. Alrighty. Wonder if I can actually get this out of here without having to. Probably not. One thing they didn't do in the old days is plug everything so that it could come off without unsoldering stuff. It was just sort of accepted. Nowadays, of course, everything would have a plug on it. Let's see. Still haven't changed the tip on this thing yet. Really need to. There we go. Wow. Well wrapped. Good mechanical connection here. One of the differences between commercial stuff and consumer stuff is how well it's put together. Yeah, no. Well, maybe. Let's see. Can I get it up? Yeah, I can. Whoops. Little hold-offs. Little standoffs. Didn't see that. Yeah, that's pretty well cooked in there. There's a nice cooked area underneath where that resistor is. So we'll take that guy out. What side? And the Zener going to it. The smell of old burnt resistor in the morning. Love it. Yeesh. Yeah, me thinks that's probably no good. Of course, we knew that. I mean, just look at it. Okay. And I can virtually guarantee you this Zener, because it's gotten really hot. What the heck? Almost. Let's see. It's gotten really hot, so. There's one end. There's the other end. Yeah. Yeah, that even got hot right there underneath that Zener. Ha! Okay, so now let's test the Zener out of circuit. And it's a piece of wire. Alright, so what do we got here? That Zener is a 4742. What is that? It is a 12 volt, 1 watt, 12 volt Zener. 4742A. Okay, so it's a 1 watt, 12 volt, through-hole Zener diode. They're 11 cents. Okay. My problem is actually going to be finding a 510 ohm 2 watt resistor. I kind of doubt it. What do we got here? Evidently, it's not really. That critical, considering this thing went all the way down to nothing. So 510 ohms, that would be 2 watts, couple of 270s, or wait a minute, give me 1.2K. Do I have anything like that? I may have to make a run. Let's see what we got here. If I take 2 of these and put them together. That'll give me. Let's see, what do we got here? Okay, well, that's good sign. Alright, so 590 ohms if I put these two guys together. $510 ohms, perfect. So what I got here? I got a 1K and another 1K. Perfect. So I got 2 1K, 1 watt, or actually 2 watts. They're calling for a 2 watt on this thing, but that's a pretty big 2 watt resistor. Okay. And a 12 volt Zener. I don't know. I'm going to look for that. I'll be back. Okay, so I checked with the powers that be, and they're perfectly okay with me putting in a couple of these guys, a couple 1 kWs or 1 kW. Ha ha! Poof! A couple of 1K resistors in parallel. No problem. There's room for it. So we'll do it like this, and like this. Now, when you do this, you have to get them going the right direction so you don't confuse the electrons. Because if you get them backwards, the resistance will be different in both directions. Yeah. Okay. Actually, I jest. It's like you always have to have black wire for ground, because if you don't, you'll just seriously confuse the electrons. Positive doesn't really matter. Unless you're an AC, and then that has to be green. Alright. That's good. Make sure you get them good and hot. Okay. And check them out here. No, that did not solder. Okay. Quite warm. All right. Okay, come on. These are very old resistors. There we go. Nicely soldered. Okay, put you away. Now I get to look through the box of parts. I do have a full set of spares, which is nice for this transmitter. You always try to have a full set of spares. Let's see, what are we looking at here? Probably got their part number on it. Whoa, that's some old stuff right there. I mean, old paper. Well, let's see, I put this thing in 1988, so this is some old paper. So we're looking for 1N4742. Not on that sheet. Wow. Basically, I'm just looking to see if 4742A. So the part number, we got 1H in here, would be 38600. 83,000. So ending in 83,000. Okay. This might take a while. What? None of these things are numbered that way. $386. 386. 0083 000 36 0083. Really? Okay. Really? That quickly? I can't believe that. Well, I don't have my tester here to... Boy! This plastic has just gone to heck. But that's what it says right there. 386 0083 000. Yeah, different kinds of, which is strange. I guess that's okay, but that's kind of strange that it's a different style. Alright. Just for giggles, let's test this, make sure she's okay. Nothing front to back, or back to front, and 0.6 front back to front. Okay. I'm just going to read this to make sure, if I can read this. Wow. Long glasses. Graduated bifocals do not work behind lenses. Okay, so we got, it says 12 volts, one end, 47, 42A. That's what we're looking for. Okay. You know what? Let us clean this up just a bit. Okay. I am not at home, so I don't have all my neat stuff here. We're just going to have to clean this up with a rag. I don't have... I gotta talk them into buying some stuff. Yeah. Did that get hot enough to break? No. But we are going to finish off that trace because it just doesn't look good. There we go. Yeah. Pulled off little bits with it, but I think it's okay. I swear, back in the old days, there was enough rosin flux in this solder wick that you didn't actually need to add any, but there isn't anymore. That's another thing I miss from home. I really ought to do, I guess. Is my little air evacuation system. It runs all the time when I'm soldering. Wow, that got really, really hot. Let's put a little on here and suck it out. Use the solder sucker because it's... There we go. That one looks good. Those look fine. Alright. There we go. So, it goes this way, I think. Let's see. One end goes right to that. Yeah, to ground. Really? Really? That's not right. Couldn't even see. Okay, so this side's ground. Well, of course it's ground. There's the little straps. Some days are better than others. And of course it's not formed exactly right, but you gotta be careful with Zehners especially. Sometimes they are just a little bit on the fragile side when you're bending over leads. Oh, there we go. Perfect. Got that just right. Alright. And then this guy. Why couldn't I have used the other resistor instead of the one with bent leads? Sometimes I amaze myself. Okay, with my dumbness. Alright. There we go. And that's in nicely. Why is... I was just looking at this. There appears to be a buildup of some sort of black stuff, but I think that's just probably from that resistor going kafloofy on us. Kapow. Yeah, this ain't exactly surface mount work, is it? Well, I don't think so. Alright. Okay. And evidently this thing's been going bad for a while. Because those resistors don't burn up overnight. That's for sure. Alright, one more solder. I think that's the iron. Long iron. There we go. And another thing to do about the burnt spot on the board, but it's not burnt enough. We do have this right there. If you can see that underneath there, that kind of bothers me a little bit. And there's a bunch of it actually on the board too. I wonder if that might just be from these resistors. Let's check those, since now I know that Zener's okay. And its associated resistor. Yeah, I'll get everybody back down into the hole here. Okay, there. Alright. Let's take this guy and find out what these are. These resistors look like wire rounds about one ohm. And they are marked as R13 and R12. R13 and R12. 0.2 at 10 watts. Okay, I'd say that that's good. That guy is in there, good. I don't know if this is going to work, but we're going to give it a shot. We're going to check these tantalums. I have had from time to time bad experiences with tantalums. When I first started in this, I thought tantalums were the cat's meow, but you can tell when I started in this, can't you? But over the years, I've kind of found out that they ain't all they're cracked up to be. They're nice and they're small, but the problem with them is their failure mode is short, which isn't a good thing. Come on, you. There. At least this will tell me if it is shorted. 47 microfarads, 0.1 ohm ESR. Oh, okay. So 47, and what are you supposed to be? 47. Okay, well that one's alright. Even in circuit it measured alright. Let's test you. And this one 8.4 at 0.6 ohms. That's cool. 6.8. I can live with that. And you over here, that's ground. And this one is in our little circuit that we were messing with. See if it's any good. This isn't looking good. Yeah, no. It's just sitting here saying nothing. Ah, there we go. 242 microfarad, 1.4K, but we don't know if that's just because it's in circuit or not. So, if I can get this off of here. Wow. Okay, thank you. Shee. All right, let's bend this back around again. So I think it would behoove us there to take this little guy right here out and check it, considering it appears to be attached to that resistor that decided to leave this world. Probably a good idea. Alright, fine. You're not going to do that, are you? Where are you? There you are. These holes that these components are through are just barely big enough. Fortunately, it's the old style boards that can take a lot of torture. Thank goodness. Alright, got her out. Let's see what she tests out of circuit here. 97 microfarads at 1.4K. Yeah, no. This is supposed to be a 6.8 microfarad capacitor. Try that again. First time. Yeah, 61 microfarads. She no good. So I need a 6.8 at 50 tantalum. Gotta go find one of those. I'll be back. Okay, well, I can't find a tantalum. One of these guys. Can't find it anywhere, but I got one of these. where this thing is located is just off the collector of this transistor. I'm sure it'll be fine. I don't need to really worry about it. I'm just going to put in a regular old capacitor. Okay. Wait a minute. Yeah, 10 microfarads at 0.31. I just, for some, wait a minute. We might have a lead problem here. Let's try this again. Because I got the same thing on that other one. 81 microfarads. No, this thing's definitely bad. Let's try this again. Because it's reading anywhere between 46 and 80 something. Yeah, this is 10. Okay. No, this guy's bad. Interesting. I got the same result. Whoops. The first time I tested it, but it's definitely shot. Okay, so it went where? Clean out that hole. Yep. There we go. Yeah, I'm just going to stick this thing in here. It's going to be fine. I promise. Making sure I put it in the right way. Really? It looks like it's clear now. Plus here, minus there. Okay. Besides, it would make sense if that thing was that cooked, that resistor and that zener, that there's probably a fair possibility that capacitor kind of took a hit. So there we go. Yep, that's good. Alrighty. Kind of surprised that these wires are still semi-flexible. Alrighty, so let's test a few other things here. Get out of the way. Thank you. Alright, I'm going to test these transistors just to be sure, because they're not actually in that circuit, but they're 2N4403s and 4401s. But and I wonder if I'm going to be able, one of them goes straight to ground. Maybe. We'll see. Two diodes back to back. But that could be because they're in circuit. So what we do, swap the leads around a little bit. Let's see if it helps. I don't really want to take them out. Boards that are this old sometimes it's not a great idea to be removing stuff. Alright, that's going to make me take them out, I guess. Not surprising. I haven't really ever found out the limitations of that little magic box yet. Okay, so it's right there. Let's add a little bit of solder to them, just to make life easier. Okay. There's one. Alright, at least they're nicely marked. This is the 4403. See what it says. Like I said, I think they're probably okay, but we'll find out. It's better to test them now than to have to tear the whole thing apart again. After you put it back into the box. And we have transistor, NPN or PNP, yeah, 0.653 or 635. That's good. Transistor's got a gain of 171. Healthy little transistor. Okay. Put her back in. Solder her back down. I'll tell you, this is real old-timey stuff here. But I like it. I guess it's only fitting considering I'm kind of old-timey stuff myself. Ooh. Okay. This one is the 4401. It also, I believe, is PNP. No, it's NPN. Interesting. Used to be a long time ago that evens were NPNs and odds were PNPs, but that was forever and a month ago. Okay. And it's showing as a good NPN with a B of, wow, beta 4.433, 6.5 millivolts front to back. Alright, she's good. Put her back in. Okay. Alright, so that's looking good. Let's check this CR3. See what it thinks it is. Probably just fine. I would be willing to bet. And no, it says it's 690 microfarad capacitor, but I seriously doubt that. So let's try it with this. It's in circuit. You never know. It's a 50-50 thing. 0.4 volts that way. And 1.6. Okay, well, just to be on the safe side. Where is CR3 in the circuit? Yeah, that's in our little setup right there. That's an MR751. It's all in that section that we just did. So, to be on the safe side. It's around all this burnt stuff, though. We'll see. She's out. And let's see what it says for this thing. Diode. 533 millivolts, 32 nanofarads, and the IR 0.25 microamps. Okay. Well, that appears to be good, but I'm going to test it static. Open that way, which is correct. And, whoops. Hold still. 0.447. Okay, so she's good. Kind of thought it would be, considering, you know, it's huge. Okay. Get back and all. There we go. Doesn't really want to be there. Crud. Crud, crud, crud. Okay. Of all the time, the hole, for everything else, the holes are really tight on this board, except for this bugger, and it's as loose as can be. Of course it is. So. There. Got it tacked in there. Well, they cut this off about as flush as they could get it. There we go. The only reason I really checked that is because it's right there at the point where all of this black glop is. So let's get the black glop out of there a little bit. Alright, so the transistors are good, that diode's good. I don't see any other burnt things. These tantalums are good. No other burnt resistors or anything. So let's just go ahead and check these diodes. 0.6, 0.57. that is grounded. That's good. Don't see a whole lot else on here, just some coils. A diode. 0.6 on that one, that direction. And yes, good. Backwards on these two that I already checked. Open, good. Open, good. Alright, well, it appears that we have okay. The only other thing I want to do is exercise these ICs. They're socketed, and did they or did they not? No. Jeez. Single-sided sockets. Just cheap sockets. Really? Harris? Seriously? Okay, make sure they're seated nicely. Well, at least this was double-sided socket. That's nice of them. You got something that's working 24/7. You would think they could spend more than 60 cents on a socket. That's just me. Who knows? Alright. Well, let's see. Put that there. That there. Alright, so let's put this thing back together. I'm pretty sure of this. I'm happy with it. Okay, here we are, back again. And she's all put back together. Whoops. Forgot that one. Okay. Make sure they're all tight, because that's what holds the lid on. And we're just going to assume that this is good because it didn't appear to have anything wrong with it. We're going to check the check this big old cap here, because it's all old, but it's good quality. I don't know what it is. That's a Nichicon, so I can pretty much guarantee you that it's fine, but let's find out. And we attach this to here, this to here. This thing's been off for a very long time, so I'm not worried about the electricity. So let's hit her up, see what she says it is. 103 microfarads at 0.03 ohm ESR. Perfect. Nothing wrong with that guy. Fantastic. So we'll solder him back down again. It's just sort of tacked right on the top of this board here. On the ground end anyway. What's the other end look like? Yep, it's tacked on there too, on the plus side. So anyway, that's back. So we've tested everything in it. All the transistors are good. These guys have been reseated. We replaced this 510 ohm resistor with two 1Ks in parallel for 500 ohms. Actually, it came out exactly 510. We replaced a Zener diode that was shorted, and this little was a tantalum cap, but I just replaced it with a it was a 6.8. I replaced it with a 10, at 50 volts, which is 50 volts is what it was. We're hooked back up here, and everything looks good. Nothing burnt over here. Can't really test these because they go, I don't think. Let's find out. Because, you know, they go through the coils, but let's see. Yeah, well, of course it says it's a short. Yeah. Well, they're all going to say they're shorts because they're, yeah, they're just a loop of wire and it goes through the coil, so everything says it's short. But that wasn't the problem with it. The problem was the power supply. These seem to be doing just fine. I'm not even going to bother. We're going to put her back into service and see if she works. Let's put the lid back on it. Get out some of this stuff out of here. Didn't make it pretty. Yeah, that all the black stuff we saw in there was all from that one resistor burning up because, well, it either changed in value and over the years, and changed in value and the Zener went out, or the Zener went out and burned up the resistor. I'm not sure which. Doesn't really matter. They're both bad, and they took out that cap with them. So we're going to put this thing back together again and take it down. I can't really hook it up. I don't have a 48 volt supply. It's good for 7 amps. So we'll put it back together, take it down, put it in the transmitter, turn it on, see what happens. But I got a good feeling about this. It's great when you finally get to fix stuff that you're absolutely sure that there's something wrong with, and pretty darn sure that it fixed it. Of course, there isn't that much stuff on that board, so we could test everything, which makes life a lot easier. And no surface mounts and none of that stuff. Just old school electronics. Love it, love it, love it. Of course, I'm kind of old school myself. Anyway, there you go. Intermediate power amplifier from a Harris 25 kilowatt transmitter. Fixed. Well, I hope you enjoyed the video. If you did, give it a thumbs up for me. And don't forget, if you want to see more of these, want to know when I do one, hit that little subscribe button and the little thing next to it so you get notifications. Thanks for watching.